Here is a test problem for you on application of trigonometry. Three circles of radii 3, 4 and 5 cm are mutually tangent as shown in the figure. Find the area of enclosed space between the three circles. So these are the three circles given to you, tangent to each other with radius of 3, 4 and 5. You need to find area of this space right in the center. Now I'd like you to pause the video, solve the question and then look into my suggestions. Well, to solve this problem, what we should do is, we should connect the center of these three circles. So when we connect the center, we get a triangle right there. Now to get the area of enclosed space, that means this space, what we need is, we need to find area of the triangle and take away area of these three sectors. If we do that, we get area of the enclosed space, right? So what we will do is we'll find area of this triangle. Now since we know the sides of the triangle, the sides are sum of the radii. So 3 plus 4 gives us 7, right? 5 plus 4 will give us 9 and 3 plus 5 is 8. So 7, 8, 9 is the triangle which we need to work with. So we can use the Heron's formula to find area of the triangle. So area of the triangle is equals to square root of s times s minus a times s minus b times s minus c. That is the Heron's formula, where s is semi-perimeter, right? So we add these three sides, divide by 2. That is the value of s. That is a plus b plus c divided by 2. In this case, a, b, c are 7, 8 and 9. So we can add 7, 8 and 9 and divide by 2. So that is the value of s, which is semi-perimeter. Now that gives us 7 plus 8 is 15. And 15 plus 9 is 24 divided by 2 is 12. Now putting these values, we can get the value of area of the triangle, which is square root of 12 times 12 minus 7 times 12 minus 8, 12 minus 9 square root. That is square root of 12 times 5, 4, 3. Now we can use calculator to find the area, right? So it is 12 square root 5. So exact value could be 12 square root 5, or we'll do 12 times 5 times 4 times 3, which is 720, and square root of 720 will be 26.83. So it is 26.83. You could also write 12 square root 5 as the exact value. So we got the area of this. Now how to find area of each sector? That is a big question. So for example, we have to find area of this sector, correct? So this sector here, how do we find that? Now to find the area of the sector, we need to find each interior angle. Once we know the interior angle, then we can have pi r square area of the full circle, then times it with the angle and divide by 360 will give us area of the sector. So that is how we can find it. Now to find the angles first, we can use cosine law, right? So let's use cosine law and find angles, each angle. So starting with, let's say A is 3 for us, then 4. We write B here and C here, let us say, right? So that becomes a triangle. So angle A should be equals to, use cosine law, square of these two sides. So it's cos inverse of square of these two sides should be added. That is 8 square plus 7 square minus 9 square, the opposite side. Divide by 2 times 8 and 7. That is the angle A, right? So we can use calculator again. Do second function, cos inverse, two brackets, one for the numerator, which is 8 square plus 7 square minus 9 square, bracket close. Now let's open bracket for the denominator, which is 2 times 8 times 7. Two brackets should be closed, equals to, that gives us 73.398, so we can write this as approximately 73.4 degrees. So that's the approximate value for angle A. Similarly, we can find angle B and C. So angle B will be equals to cos inverse of, so angle B we are going to add squares of 7 and 9 this time. So we have 7 square plus 9 square minus 8 square divided by 2 times 7 times 9. So that will be second function, cos inverse, two brackets, 7 square plus 9 square minus 8 square, bracket close, divided by 2 times 7 times 9. It gives us 58.41. So we can write this as 58.4, let us say, degrees. So we got angle A and B. We can also find angle C. So angle C will be 180 degrees minus sum of these two. So I'll say 73.4 degrees minus 58.4 degrees, and that is equals to, so we have 180 minus 73.4 minus 58.4. That gives us 48.2 degrees. So now we know all the three angles. Now since we know the angles, we can find area of each sector, right? So let's start with the smallest area. Let me call that as area 1, right? So area 1 will be pi r square, which is pi, radius is 3 square. Angle for A is 73.4. So that is 73.4 divided by 360. Let me put it in brackets, divided by 360. So that is area of the first one, right? Which is equal to, so we'll do pi times 9 times 73.4 divided by 360. That gives us 5.76. So we'll write 5.76. Now area of the second one, sector will be, let's take this one, which is pi times 4 square, and the angle for B is 58.4 divided by 360. That gives us, we'll do pi times 16, 4 square, times 58.4 divided by 360. So that is equal to 8.15. And area for the third sector will be pi times 5 square, which is 25, and the angle is 48.2 divided by 360. So it is equals to pi times 25 times 48.2 divided by 360, and that is equal to 10.51. Right? So we get this total area of sectors is A1 plus A2 plus A3. Area of triangle is 26.83, right? So area of the space, enclosed space, is equals to area of the triangle, which is 26.83 minus sum of these three, which is 5.76 plus 8.15 plus 10.51, correct? So let's calculate this one now. So it gives us 26.83, take away sum of 5.76 plus 8.15 plus 10.51, and that is equal to 2.41. So we'll write centimeters the unit, centimeters square, right? So we get our answer, and that is answer is equal to 2.41 centimeters square, correct? So that is how you can find enclosed space area, right? So let's go through these steps. This is an excellent question. Now we were given 3 circles which were mutually tangent with some radius 3, 4 and 5 this time, making a scalene triangle. So when you make a scalene triangle, then you have to use Heron's formula, right? So this is the application of Heron's formula, which is, so for that we need to find the semi-perimeter, which was 12, and using the formula we found the area of the triangle, which was formed by the centers of these 3 circles. It came to 26.83. So that one is important figure for us, area for the whole triangle, right? Now, so this is the triangle, the orange triangle which we have. Then we found the angles, each angle. So each angle was calculated. 73.4, 58.4 and 48.2 were the angles. Then we calculate the area of the sector. So these are the sectors, right? So area of the sector is ratio of the area of the circle with angle of the sector divided by 360 degrees. So we got the 3 areas of the sectors. So area of the enclosed space was area of the triangle. This is the whole triangle. Take away the area of the sectors. So that gave us 2.41 centimeters squared, and that is how we calculate the area of the enclosed space. Thank you.